Assalamualaikum warahmatullahi wabarakatuh. We are going to discuss about COVID-19 trends, which is a case study of Sarawak in April 2020. Our group consists of 3 members, which is Nur Alia Hidayu binti Azani, Nur Akilah Inshirah binti Muhammad Ruzi, and Cik Nur Farhanalia binti Cik Din. We will discuss about introduction, objective, methodology, result, and conclusion.
COVID-19 is equal to coronavirus disease 2019, or also known as severe acute respiratory coronavirus 2. It was found in Wuhan, China on December 2019, and it was spread fastly around the world and enacted a pandemic lockdown in Malaysia by World Health Organization WHO. Here are the symptoms of COVID-19 like cough, headache, and fever. There are 7 phases of movement control order MCO starting from 18 March 2020 until to 28 June 2021. Our project data is about COVID-19 with a total cases per day in Sarawak on April 2020. We use least square method, which is known as efficiency processing data, and provide a visual representation for the connection between data. In this study, we use two methods, which is linear and quadratic, and we use date for X and total cases per day for Y.
The methodology of this study is to predict the trend of COVID-19 in Sarawak in April 2020 and to calculate the major standard error. Next, we move to the methodology. In this study, we focus on the least square solution to predict the trend of COVID-19 cases in Sarawak during April 2020. Why we need to use least square method? It is because least square method is used when there are many systems of linear equation that need to be solved. The uses of least square method is to minimize the error between the predicted and actual values. How least square method exists? Least square method was founded by Adrian Mary Legendre in 1805. But after 4 years, Carl Friedrich claimed that he had been used the method since 1795, and he continued to improve the method. Least square method is to find the straight line and or the curve that best fits by minimizing the square difference between the observed and predicted values, which is called magnitude of error. The lower the major standard of error, the model is more accurate. There are 3 types of model that can be used, which is linear model, quadratic model, and cubic model. Here are the steps for obtaining the magnitude of error of linear model. Firstly, write the data in linear model, which is in the equation of y equal to mx plus c. Next, for the step 2, convert the data in the form of a system linear equation, which is ax equal to b. That means we need to identify the matrix of A and matrix of B. Next, for the step 3, solve the system using least square method, which is A transpose X equal to A transpose B. So we need to find the X value by A transpose A inverse multiply with A transpose B. The X value is the value of M and C. So we can obtain a straight line equation from that value. Next, for the step 5, we need to check for the least error value by finding the error b minus ax. And the magnitude of error, we need to square root all the value of error square. Lastly, we need to compare the magnitude of error value with another model. Next, here is the step for obtaining magnitude of error for the quadratic model. Firstly, write the data in quadratic model, which is in the equation of y equal to ax squared plus bx plus c. Next, for the step 2, convert the data in the form of a system of linear equation, which is ax equal to b. We need to identify what the value of matrix A and matrix B. Next, step 3, solve the system using least square method, which is A transpose x equal to A transpose B. And the value x obtained is by using A transpose A inverse multiplied with A transpose B. Step 4, x value obtained is the value of A, B, and C. So we can obtain a quadratic line equation from that value. Next, step 5, to check for the least error value, we need to find for the error value, which is B minus with AX. The magnitude of error is by square root the value of square, all of the error square. Lastly, we need to obtain the error value and compare it with another model. The lower the magnitude of error, the more significance of the model.
Create a matrix A size 30 by 2 using date and the matrix of B size 30 by 2 using total cases per day. Why?
Step 2. Create a transpose matrix of A by copying and pasting the data using the paste transpose function in order to convert the data from vertical to horizontal without typing each value manually. Using this is essential to help the user save time from keying each value in manual way. Step 3. Using the mMult function for multiplying the transpose matrix with the original matrix. The matrix multiplication mMult method is used to return a matrix that multiple to arrays. When the number of rows in matrix 2 equals the number of columns in matrix 1, both matrices can be solved, and the final matrix will have the same number of rows in matrix 1 and have the same number of columns in matrix 2. Step 4. Multiply the matrix B and matrix of A transpose using the mMult function. So here are the outcome. For step 5 is, an inverse matrix should be calculated using the answer of multiplying matrix from step 3. By using M inverse, the identity matrix will be created. An error message will be written if the matrix is not in a non-singular form. So the outcome will be like this. Step 6. The least square approach, which makes use of the mMult function, must be used in order to solve the problem. Step 7. In order to find the residual E, the matrix of A, original matrix, must be multiplied by least square solution, X matrix, using the mMult function. Then, using the value of matrix B minus by values of matrix AX, therefore the residuals found. Step 8. Use the values that have been calculated in residual E matrix, find the E square matrix. Then, using sum function, find the total of E square. At last, using the total of E square, find the square root of it. Therefore, the magnitude of error has been found, and the magnitude of error for our project is 34.72 for linear system.
For the quadratic model, the explanation on the Excel command used in the solving system is firstly create matrix A with 3 columns, which is the first column representing the square value of x, which is x squared, the second column representing x, and the third column representing the constant term, which is 1, while create matrix B that represent y. Next, to get A transpose is select the range of cells you want to copy and right-click on the selected cells and choose copy from the context menu. Select the destination range where you want to paste the transpose data, then right-click on the destination range and choose Pass Special from the context menu. Lastly, in the Pass Special dialog box, check the transpose option and then click OK to pass the transpose data. Next, use the matrix functions. In Excel, you can use the inverse function to find the inverse of a matrix and the mMult function to multiply matrices. To calculate the coefficients in a new section of your worksheet, use the mMult function to multiply the inverse of the matrix by the column vectors of sum. This will give you the coefficient of the quadratic equation, which is A, B, and C. Then use the coefficient. With the coefficient calculated, you can now use them to form the quadratic equation and make predictions and plot the curve. And lastly, enter your actual values or observations and the predicted values into separate columns in Excel. In a new column, subtract the predicted values from the actual value to calculate the error vector. This will give you the differences between the predicted and actual values for each data point. To calculate the magnitude of the error, use a suitable error matrix such as the square root of the error vector. The formula can be used like stated on the slide, where error vector range is the range of cells containing the error vector. The comparison of error for linear and quadratic polynomial can be shown as below. The magnitude of error for linear curve is 34.7204, while the magnitude for the quadratic curve is 32.9727. Hence, the best method that can be used for this study is quadratic equation method, since it has smallest error magnitude of error compared to the linear equation. Several important conclusions can be drawn when the objective of predicting the trend of COVID-19 in Sarawak for April 2020 and calculating the major standard error are achieved. The prediction of COVID-19 trends provide critical insight into whether cases are likely to increase, decrease, or stabilize during this period. This knowledge is essential for policymakers and healthcare authorities to make informed decisions regarding public health measures, such as implementing or relaxing restrictions and allocating resources. The calculation of the major standard error further strengthens the analysis by quantifying the uncertainty or variability in the prediction or estimates. A smaller standard error suggests higher precision, increasing confidence in trend forecast, while a larger error indicates greater uncertainty, urging caution in interpretation. Overall, achieving this objective enables data-driven decision-making and enhances preparedness and response